Okay, let's get started. Today's class. Before we're talking about the content, first let me say something about this project, term project. So all of you should already see your group assignment as well as the requirements for the term project. Right now we have one thing that's due this Friday. It's gonna be the project planning part 1. Okay, so there are actually 6 subsections for a project plan, include a scope, a schedule, team organization, technical description of the system, data management plan, and the test data. Okay, so what we are going to do for this part 1 will only include this scope of the project, the team organization of the project, in which you need to include the resumes from all your teammates. Okay, so please try to set up connection with all of your team members, since this is due on Friday. Okay, it's Friday, right? Yeah, it's due on Friday. So if your teammates submit, if the team submit the resumes without some of the names there, that means that member is not getting connect with the group. So okay, so that if that's the case, well, I will give the credits of the assignments to whomever submitted the resumes. Okay, and if your name is not included there, you will lose this the credit for this project plan part 1. All right, so it's gonna do on Friday the midnight. It's a 11:58 p.m. all right. Okay.
And you answered me. So far, we tried to connect with each other, but still, they reply very late, and one of them they didn't reply yet, and we actually we were very confused how we have to. What do you expect for scope? It's exactly what is our idea, what do we want to do this project. This is what your expectation of the scope.
Yeah, exactly. That's exactly the thing I'm going to talk about. So that's why I ask everyone to read every material carefully. So here, if you go to project planning, there's a material about project planning. Okay, so here we have explanation to everything there, including scope, schedule, organization, this description. So scope here, well, the definition, we keep every definition. Scope usually just cover what the customer wants to build, as well as specifying the system boundaries and what will be included in the project, as well as what is outside the scope of project. So it's you describe this thing, this functionalities, the boundaries from a very high level, very overview level. It can be only just a paragraph. That's called scope, because it's not like specification of all the functionalities, of all the requirements. Okay, and it's not specification of the use case, which we will do later today. It's just from an overview point, from a high level, what is the project.
You care about how long it should be? 1 page in a
No, it's not 1 page, just 1 paragraph,
One paragraph.
just 2-3 sentences, something like that, or 3-4 sentences.
How about data management plan?
Yeah. So data management plan, let me show you. Yeah. So number 10 is the data management plan. So you just describe how data will be gathered, stored, because there is, if there's a system, there will be data. Okay, so you just describe how the data, you get the data, how you store them in the system, right? It's not regarding anything about what data. It's just talking about the data in general and how will you deal with them. Yeah. And sometimes, cause maybe you don't feel that way. Sometimes the data is not sensitive to some of the project, but to some of the very sensitive project, maybe it's all about just collecting data from users, and you want those data, you want to keep the data secure. Then the data management plan makes more sense. But here I just want you to try to learn how to write the data management plan. Just include these points, just how data gathered, and when you want to transfer the data, maybe you do this through the internet, or if it's too sensitive to go to internet, it's only we do it offline, right, by some devices, hard drive, something like that. Are they are they protected? Are those data protected? Are they encrypted? Are they password protected? Something like that. And how are they stored? How will you handle those data? And maybe if there any like a security level to access this data within the company, something like that. Okay, so that's the data management plan.
And one more in this class, excuse me, is it possible if ours okay that you extend this deadline if it's okay for you?
Well, I'll decide that later, because today we still have 5 days. Oh no, we still have 4 days, 3 days, 3 days. So it's not a good time to decide if we should extend it, right? Well, I'll decide it maybe later in the near Friday, sometime like that. So please pay attention to the announcement in D2L. I think all the announcements, they are forwarded to your email, right? Are they?
No.
No?
You have to set it up.
You have to set it up.
You have to set it up on D12 if you want to get notifications.
Okay, just try to, well, because I send a lot of announcements usually, so please set up with the connected announcement with your email. Right, thanks. So that's about project planning, a term project. Then let's go back to our UML. Okay. Let's talk about class diagram. You still remember what we talked? What's the meaning of each of these different notations? Let me ask you, what does this mean? This diamond?
It's the aggregation.
Yeah, it's called aggregation, exactly. So what do you mean by, what is the aggregation?
It's a part of another class.
Yes, part of another class. So which one? Let's say, what is the direction? So here we are connecting course and course offering. Which one is the part of the other one?
The course offering is a part of the course.
Yes, exactly. Yes. So here course offering is a part of the course. Like if we have a class of human and we have a class head or hand or leg, they are part of human, right? So if we want to model human, we have a human class, then we put the diamond mark there at the human, and we connect the line from human to the hand or head, something like that. Okay, so that's the, yeah, probably we can call it, it's actually has a relationship, means course has a course offering, okay, and human has a head, right? Okay, and how about this one, this triangle? Yeah, it's basically a superclass and it's a subclass. We call this inheritance, or we call it we also can call it like the is a relationship. Do you know why it is a relation? Is a. Yeah. Like student is a registration user. Professor is a registration user. Student is subclass of registration user, and professor is subclass of registration user, right? Also, we can say a bag. Okay, a bag. Well, there are a whole bunch of bag, handbags, school bag, backpack, those kind of different kind of bag. So, if we have three classes: bag, handbag, and backpack, which one do you think is the superclass? Bag, right? Bag, yeah. Bag is a superclass. Handbag is a bag, right? And yeah, the school bag is a bag. So we need to figure out the relation between the superclass and subclass. Okay. And for the class diagrams, you need to also remember, well, it has three sections. The top section is the name of the class, and the middle section is the attributes of the class, and the lower section here, like open of the course offering, open 8 students, that's the functions, or you can say operations of the class. Okay, so we use class diagram to clearly show the relations of all the classes in the system. Okay. Okay, and following this class diagram, we have a state diagram. We talk about a little bit about the state of the diagram, state of an object. So state of an object, it is decided by the value, right, of the attributes. Okay, so here, let's say this okay, course offering, it has the attributes called location, maybe another attribute called number. Okay, so when we have an instance, I mean the object of the course offering, okay, if the location is set to J157, then that's one state of the course offering. If the location is set to some other value, J202, that's become another state of this course offering. Okay, so class, the object created from the class, the object actually has different state. The light has on and off state, right? It has the attributes called on or off, something like that. So when we talk about state diagram, something like this, we have starting point, we have end point, but what do you think when we talk about a state diagram, what do you think this state diagram describe? It describes the change, right? The changes of the state. So that's state diagram. Okay, so it describes a change of what? What is changing?
Students in the classes.
Yeah, here in this diagram, yes, it's a student. Let's see, course. Yeah. So it describes the change. I believe it's the course offering class. Yeah. So actually, when we talk about state transition diagram, it's a state transition of a single class. Remember this. It's a state transition of a single class. All right. So we can, because there are some a lot of dynamic change in the system which happen during runtime, right? So only using the class diagram is not enough to describe the features of the system. That's why we have the state transition diagram to help us to model the system. Okay, if you have some of the UML tools, when you actually modeling of the state diagram, when you actually modeling the class diagram, when you click the one of the class, you can actually have the option to see the state transition diagram of that class. Okay, because state transition diagram describe the change of the state of a single object. Okay, and the object is created from the class, right? So a single object. Got it? It's got state transition diagram. Okay, pretty nice. Now, well, these two diagrams are really important and they're very useful. So let's do a little exercises about the class diagram and state diagram. Now think about a banking system with a user, with account. User has an account has a balance, and the the system is for the ATM machine. All right, ATM machine. You withdraw the money to something like that. Okay, so now I want you to model the system of the ATM machine. Draw a simple class diagram. Think about what is in the diagram, and then think about what classes should we have. Well, maybe a suggestion, you need to have at least a user account. You have the machine, and in the account you have a balance, right? And something else you think it should be there. Okay, and then I want you to pick one of the class and generate a state transition diagram for that class. Okay, state transition, you still remember? So we have a starting point, and we have the state, we have change from one state to another, and the conditions, yes, and we have end. So that's pretty easy. It's easy to understand, and this is the example of this class diagram. Now let's start with the class diagram for the ATM machine. Do not search online. There are a whole bunch of ATM machine examples online, but I want you to think about how to use these notations, this aggregation, this inheritance, this association to generate this class diagram. What's the relation between user and account? Maybe user has an account, something like that. And how do we generate, describe the dynamic behavior of a class? Okay, let's do that for maybe 10 minutes. All right, now it's 5:30. Okay, let's do that for 10 minutes. Okay, try to use a piece of paper, or if you prefer, you can use a computer, something. Yeah. pause. So if you're an online student, you can skip watching this. Well, if you're an online student watching this video, you can skip the next 10 minutes.
What was the question again?
The ATM machine.
18.
Yeah, modeling the ATM machine. Alright. Get back to the problem. Seems you're still working, so let's have another 3 minutes. Okay. Yeah. Now, okay. Let's have a. Do we have a volunteer who can share with us your class diagram? Cool. Nice. Just there are a lot of potential correct answers, so I don't want to share some standard answers that requires you all do it that way. Instead, I will just well, let's see the example from the student and try to see if there's any issue or what is a good design. Do you think that's a good design, or you think there's any issue there? Just discussion, because there's no absolute correct answer there. cross looks cool.
Okay, that's that.
Okay, how about your state diagram for? Okay, it's fine. Yeah, let's look at this.
The start and the finish.
Yeah, you can finish a static diagram if you think. Yeah, maybe I'll do this. That's okay. Yeah. Okay, let's put the computer here. So the arrow do this. Alright, so we have some of the classes here. User, we have account, checking, savings. So yeah, I think this makes sense, right? This, well, you have a checking account, you have a saving account. They are both accounts. So account is the superclass, while these two are subclasses. Yes, and user and account. User and account. So, do you think we can do something else between user and account to specify their association? Remember this diamond? Diamond, we call that PESA. Right? And the triangle, well, is so here,
So you can put a diamond.
yeah, probably we can do like make account as a part of the user class, right? 'Cause user, they're supposed to have account in the banking system, right? So maybe this is better. And the name, yes, account, checking, saving, yes. Okay, so here you think deposit is a part of checking account. And withdraw is a checking account. Deposit and withdraw, you can doing both these two to saving and checking, right? So that's what you're talking about. Yeah. So, well, I have maybe two suggestions for this part. First, if we want to make the deposit and withdraw a separate class, right? And since they are all actually a part of both of checking and saving, and we only have a checking and saving. So what we can do is here, instead of connecting this, so you see there are a lot of lines around, but what we can do is hopefully this way. Get this point? Because you're saying that checking and saving, they both have a deposit and a withdraw class as a part of them. So what we can do is, well, we can make the deposit and withdraw class a part of its superclass. So these two actually, they are inherited to saving and checking, right? So that's following your opinion. But here, what my suggestion is, since the deposit and the withdraw, they're really not, well, class actually, because they're, you think that's a verb. Usually, if it's a verb, we do it as a operation or method instead of a class, right? So here we can do is, here we put the third column here. Put deposit and withdraw. And we do the same thing for the saving account. Right? So deposit and withdraw. Right? Is there any way else to do this? Think about superclass inheritance.
Who's in the account?
Yeah, we can just put this to deposit and withdraw method here in the account. Maybe in the saving and checking you have different deposit functions. It's possible, right? But what we can do is put them here, and then here we can override the function or rewrite the function, something like that. Okay, so that is right here. Okay, now let's pick maybe account. Let's pick this class. Try to draw some state transition of the account. Okay. All right. So basically, for a account, it has the account number as well as the balance, right? Usually in bank account you should have a balance. So let's think about this account. So we have a starting position for the account, and then here we initialize this account. Initialized account, in which the balance should be 0, right? Yeah, it's 0. Usually the balance is 0. Okay. So what else can we do to the account? What else? What can we do to the account? We have initialized. We can deposit to the account, right? Right. So here is it's an initialized account. This is standard, maybe standard account. So, well, I mean standard account, I mean the balance greater or equal to greater than 0. Okay, it means something there you can spend the money, right? So available, or I can say it's available account. Standard available. So what is the condition here? The transition from initialized account to the standard available account.
That's more than $0.
Yes, balance greater than 0. Okay, then what else can we have? No, that's balance, not deposit. Well, it's not the deposit because well, let me finish this part first, and I'll talk about that. Okay, here the condition transition from initialized account to the standard available account is balance greater than 0, and well, if you deposit something like you deposit 0, it's 0. It deposits 0, it's still 0. Right? So you have to make the exact condition, the balance greater than 0. Right? And then we should have another state. Think about it. Sometimes if you account balance goes to negative, what is it called? Yeah, overdraw. That's the overdraw account. So how can we okay, we can go from initialized to overdraw account. We can go from standard account to overdraw means balance less than 0. And we can also go from here to overdraw account. When balance is below 0. Okay. Alright. So what else can we do here for the account? Is there anything else we can do? We can close the account. Yeah, something like that, right? We close the account. We just close it. Actually, from any state, we can just close the account. And the condition is the same. It just says close. So if we want to change this something like what we just suggested, deposit. Say here, if we like deposit, okay. Another thing is you can go back from withdraw, overdraw to this standard if the balance, right, goes up. So, well, one important thing is, you see, there are a lot of maybe more than one lines coming out of one state, okay? So you kind of want to make sure that the conditions for each of the output is different. Do you know why? Do you know why? Because from here, we need to exactly know how the initialized account can become an overdraw account that is balance less than 0. If we have some similar same conditions for here and here, like withdraw money to balance less than 0, or the bank has a policy, if you withdraw too much of the money, I will close the account. If we put withdraw here, and also withdraw here, okay. So when we are in this state, whenever withdraw happens, we don't know which way we should go. Right? We need to exactly specify how the system will change. Okay, we should avoid ambiguity. So here it's ambiguous. Withdraw and withdraw, we don't know which way should we go, right? So conditions should be different. Okay. So that's a part of the class diagram. Okay, then we're going to talk about something like the requirements. How do we gather requirements from the users? Okay. Do this later. Okay, when we're going to gather a requirement from the user, you know what is requirement? Requirement means the thing that when we talk to the customer client, we try to figure out what is the actual needs from the client. So what the system should do, right? All right. So there are a bunch of ways to gather the requirements. Maybe you just do it by talking. You understand everything, but here we gonna introduce a useful tool that is called a use case flow. Use case flow, not use case diagram. Use case diagram is another thing. This is called use case flow documentation to help us to gather what is exactly the behaviors of the system. What exactly should the system do? All right. So it's a technique to capture the potential requirements of a new system, or capture the requirements to change a system. Okay. Or each use case will provide one or more scenarios that convey how the system should interact with the end user or another system to achieve a specific goal. So it has the user there, and it's describe the user is doing something, how the user is interacting with the system. Now let's see example here. So a use case documentation looks like something like this. First, it has a title, like the name of the use case. In this case, it's called flow of events for select course to teach. So the event happening here is the user is trying to select courses to teach. Okay, and the preconditions here, 1.1 preconditions here, we need to specify, okay, when this event happening, what should be already being done. In this case, the precondition is the create course offering subflow of the maintain course use case must execute before this use case. That means the course should already be created before you're executing this use case flow. Get it? If you want, okay, let's change it to another way. If you want to select courses to teach, the course should be created already, right? Yes, good. All right, then we will have a main flow. 1.2 main flow, the subflow, and the alternative flows. Okay, what are the difference between these three flows? Let's see. Okay, so here we have some of the description. So this use case begins when the professor log into the registration system and enter his password. The system verifies that the password is valid. Here, look at here. Can you see that clearly? Or do you want me to zoom in? Okay, the main flow, see this? Okay, so here it's described, okay, this begins with the professor logging in the user password. It just describes what the professor is doing interacting with the system, right? Describe the logo registration system, enter password system, and then after the professor's action, the system verify the password is valid and prompt the professor to select current semester or future semester. Here at the place here we have a E1 here. E1 here. So if we do not look at this E1 thing here, the system verify the password is valid and then do something else. Do we see anything is missing here? In this part, the password is valid. Yes, exactly. It can be invalid, right? So that's the main flow. Main flow means maybe a general flow that you successfully doing this thing. I go through, I log in, I select the course, I put them into my schedule. Nothing else happens. There's no exceptions, something like that. But however, it doesn't work that way. In the real system, we need to consider different situation. The password may be invalid, right? But that is not in the main flow. So here in the main flow part, we just describe a general events flow that maybe successfully you process this use case. Okay, but here we think, okay, here we may have we should have a invalid password situation. We need to describe that somewhere, right? So here we put it mark as E1. That means actually here we have alternative flows. Let's say what is E1 here. See, an invalid professor ID number is entered. The user can re-enter the ID number or terminate the use case. Okay, so it's an invalid username or password. That's alternative flow. Okay, so here, let's continue read this. Then prompt the professor to select a current semester for a future semester. Here we have E2. Guess what is in E2? Yeah, it should be something related to the semesters, right? Yeah, let's see. An invalid semester is entered. The user can re-enter a semester or terminate the use case. It could be a past semester because what done has already been done. So you cannot select a course in the past semester to teach, right? You do not do time travel. Well, before we can do time travel, that's gonna be illegal to the system. So here's the E2 here. But in the main flow, we just still keep talking about what everything goes smoothly. It goes through the system, finish that task. Okay. So the professor enters the desired semester. The system prompts the professor to select the desired activity. They have 4 different activities. A, the delete, review, print, or quit. Then see here, we have a branch now. We have a flow that professor enter password, open the system, open, okay, then password, then select semester. Then now here we have 4 branches now, okay? A, add, delete, 5 branch. Add, delete, review, print, and quit. That means it's not in the main flow now. We need to go to these branches, each branches. So that's when we go to this subflows. Okay, we have main flows, subflows. Main flows is like, well, if you think about the tree, you have this, yeah, you have this tree and the branches. You have the main thing and the branches. And then if you go to any of this, add, delete, review, print, and quit, they are all in this described in the subflows here. Subflows. A, the course offering, that's an add, right? So the system displays the course screen containing a field or course name and the number. The professor entered the name and the number of a course. Here we have E3. We can guess. E3 means maybe the name number is invalid, right? And the system display the course offering for the entered course. Here another alternative flow, E4. Guess what is it? The system display the course offering for the entered course.
The course can't be shown. It's not there.
Yeah, can't be displayed. Yeah. This option is not valid at this time. And in this alternative flow, it also describes when this kind of exception, something like this happen, what's next. It's not system just not stuck there. It's going to, the use case will start over. Okay, it goes to the main flow to start over. Also, in the system display course, the professor select the course offering. The system links the professors to the selected course offering. The use case then begins again. So E5 seems like, well, we have some exceptions. Here, a link between the professor and the course offering cannot be created. For example, if I want to teach a music-related class, the system won't allow me to do that because I'm not a professor in that department. Right, so that is this description here. All right, so that's an add, and then we have delete, we have review, we have print. They are the same. They are different branches. There are different branches from the main flow. Okay, from the main flow, and we have different. Maybe you can call it exceptions, alternatives. Maybe better to say exceptions in both main flows and the subflows. Okay, but you need to mark clearly where are this maybe exception flows or alternative flows. Okay, so remember 3 parts: main flow, subflow, and alternative flows. Okay, you use these 3 kind of flows, combine them to describe comprehensively describe this use case, to figure out what exactly the system should do. Okay, so there are a whole bunch of use cases. This is only one of them, right? This is the use case for a select course to teach, or you may have a use case for select course to take, right? And as described here, create course offerings, right? And no, the main course, the maintain course use case, something like that. You can have different use cases for system. And this kind of document style, this style of documentation will help you to figure out the system's functionality. Well, comparing, think about when you're just talking to the user. Okay, I'm just writing down. First, the system needs to offer the course. Then the system needs to let the teacher select the course. Okay, we may have different understanding given this kind of abstract description of the system's functionalities, right? But here we use this kind of documentation to help us figure out what exactly is the system is doing. We're trying to reduce ambiguity from the description of the requirement. Actually, requirement is very hard to do sometimes. Well, not sometimes, it's always very hard because there are always barriers in the communication between the teams and the client, because sometimes they speak different language. By the different language, it can be literally the language different, or it can be, well, their mindset is different. They're talking about different terms, right? Those different terms. All right, so that's this use case flow of event documentation. Well, that's the concept here. We have all these parts: the name, precondition, and then the flow. The flow have 3 different flows: main flow, what's the second? Alternative flow, the subflow, and the alternative flow, right? Yeah, main flow is, well, before you have a branch, it's a main flow. From start to the branch, it's a main flow. And when you're talking about those branches, like add, delete, review, print, it's going to be the subflows. And embedded in main flow and subflows, there are alternative flows, which describes a whole bunch of exceptions there in the system. All right, those exceptions, what happened during the exception, and what is the response of the system when this thing exceptions happens, right? Okay, we will talk more, maybe have a practice on this use case event of flow next week. All right, thank you very much.